Welcome viewers, in this video we'll see the solved problem based on the Norton's theorem contain DC circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Obtain the Norton's equivalent circuit of the terminal A and B for the network shown below. So the network is available. We need to find the Norton's equivalent circuit. So here we have 100 voltage source is available, voltage source 100 voltage is available, another voltage source 20 voltage is available. This is 1 ohm, 10 ohm, 2 ohm, another 10 ohm is available. This is the terminal AB. Normally it is called as a load terminal. Here in this problem only we need to find the Norton equivalent circuit. Further there is no calculation. Only Norton equivalent circuit is needed. Between the terminal AB, normally it is treated as a load terminal. So the Norton equivalent circuit is nothing but short circuit current source, one current source in parallel with the Thevenin resistance with the terminal A and B. This complicated circuit should be converted into current source in parallel with the Thevenin resistance. How to find this current source? This current source is nothing but this is the short circuit current. That is terminal A and B is short circuited and we need to find what is the current flowing through this terminal A and B. That is nothing but ISC. Then R Thevenin is nothing but the resistance between A and B. By removing this voltage source, either voltage or current source should be removed. Here two voltage sources are available. We need to remove the two voltage sources and we need to find what is the resistance across A and B is nothing but R Thevenin. Right? So we need to find short circuit current across the terminal AB flowing through the terminal AB, then R Thevenin across the terminal AB. So first we will find the ISC. Step 1 is nothing but finding the current ISC. To find short circuit current ISC by short circuit the terminal AB. This terminal AB is short circuited. Right? Now we need to find what is the current flowing through the AB. So we will take this is the loop method, KVL, Kirchhoff's voltage law, using the loop method. So this is the first loop. Loop means closed circuit. This is the another closed circuit. The current will not flow through the 10 ohm because here the short circuit is available. So the current will try to flow the shortest path, short circuit path. So current will not flow through the 10 ohm. Right? So this is the first loop. Current flowing through the first loop is I1. This is the second loop. Current flowing through the second loop is I2. Since AB terminals is short circuited, current through 10 ohm is 0. There is no current flowing through the 10 ohm resistor. So the short circuit current is nothing but I2. The current I2 is flowing through this. That is nothing but ISC. So short circuit current is equal to the loop current in the second loop I2. Right. How to find this current I1 and I2? We will follow the matrix method. This is voltage matrix, current matrix and resistance matrix. V equal to I into R. Right? This KVL method separate videos are available. First we will find the resistance matrix. This is R11, R12, R21, R22. What is R11? The total resistance available in the loop 1. The loop 1 ohm is available and 10 ohm is available. So 1 plus 10. Right. This R12 or R21, that is nothing but the resistance commonly available between first loop and second loop. So this 10 ohm is available in both loop 1 as well as loop 2. So that should be written in negative. Other than diagonal, all elements are negative. So minus 10, minus 10. R12 as well as R21. Then R22. R22 is nothing but resistance available in the second loop. This is the second loop. What are the resistance available? This 2 ohm and this 10 ohm. Right? Another this 10 ohm, 2 ohm, another this 10 ohm also available. Right? So this is the resistance available in the second loop. 10 plus 2 plus 10. Right? It is 10 plus 2 plus 10. Then the current is I1 and I2. The voltage available in the first loop is 100 voltage. The loop 100 voltage is available. In the second loop is a 20 voltage is available. This 20 voltage, right? So voltage matrix, current matrix and resistance matrix. I will go for the further simplification. So this 10 plus 1 11 minus 10 minus 10 22. 10 plus 2 plus 10 22. Right. So while calculating resistance we need to take it into account. But the current is not flowing through the 10 ohm. But while calculation this 10 ohm also taken into account. So this is nothing but the delta value. Del value. Right. So del is nothing but 11 into 22 minus of minus 10 into minus 10. Right. So 11 into 22 is 242 minus 100. 10 into 10 100. So these two negative got cancelled, but already one negative is available. So 242 minus 100 is 142. Right. Now we'll find delta 2. Delta 1 is not needed because the short circuit current is I2. So the delta 2 is enough. No need to find delta 2. Delta 1. What is delta 2? The second column should be replaced by the voltage matrix. If you replace first column with voltage matrix, delta 1. Second column by voltage matrix is delta 2. Right. So 11 minus 10. This second column is replaced by 120 voltage matrix. So 11 into 20 minus of 100 into minus 10. Right. So 11 into 20 is 220 plus 2 negative 2 times available. So it becomes positive. 100 into 10 1000. So it is 1220. So delta 2 value is 1220. So the short circuit current ISC or I2 is nothing but delta 2 divided by delta. 1220 divided by 142. That is 8.5 ampere. So we calculated the first value, short circuit current. That is the current flowing in the second loop, I2 is 8.5 ampere. Right. Now we'll find the R Thevenin. R Thevenin across the terminal AB. So what is R Thevenin? The resistance available between A and B. These voltage sources are removed now. These voltage sources removed. The equivalent resistance available A and B is nothing but the Thevenin resistance. Right. So see this, at this point the current is divided. Right. Here also again current is divided. So 1 ohm and 10 ohm are connected in parallel. We need to refer the resistance from this side onwards, not from this side. Right. We need to flow, current is flowing here. So it is divided here. Again it is divided. So that 1 ohm and 10 ohm are connected in parallel. Right. So 1 ohm and 10 ohm are connected in parallel. So R equivalent equal to R1 into R2 divided by R1 plus R2. That is 1 into 10 divided by 1 plus 10. So 10 divided by 11, it is 0.91 ohm. Right. Now these two resistors are simplified with the value 0.91 ohm. Now we'll go for the further simplification. So for this 0.91 is now redrawn. Now the circuit is become like this, 10 ohm, 2 ohm and that equivalent to parallel resistance are become 0.91. So from here we can identify that these two are connected in series. At this point current is divided. Right. So this 10 ohm, this 2 ohm and 0.9 ohm same current is flowing. That means these two are in series. That is parallel with the 10 ohm. Right. 0.91 ohm and 2 ohm are connected in series in parallel with the 10 ohm resistor. Right. So that it is 2.91 is parallel with 10 ohm. So R1 divided by R2, R1 into R2 divided by R1 plus R2. 2.91 into 10 divided by 2.91 plus 10. So that it is 29.1 divided by 12.91. That is equal to 2.254 ohm. So the Thevenin resistance is 2.254 ohm. Now we got the short circuit current as well as the R Thevenin. So from that we can draw the Norton's equivalent circuit, step 3. So this is short circuit current source in parallel with the Thevenin resistance. So the current source is 8.5 ampere. The Thevenin resistance what we calculated 2.254 ohm. So this is the Thevenin equivalent circuit with the terminal A and B. There is no further calculation. Only the equivalent circuit is necessary asked in the question, right? So in this problem, the complicated circuit we converted into Norton equivalent circuit. That is current source in parallel with the Thevenin resistance. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.